All right, let's practice writing some formulas of simple ionic pairings. When we look at lithium and phosphorus, what we're going to do to write the formula is we're going to write their ions formula. So lithium is found in 1A, which means it has one valence electron that it's going to lose when it becomes ionized. When it loses the one valence electron, and it's doing that to satisfy the octet rule and become stable, so when it loses that one valence electron, what we're going to end with is a charge of a 1 plus. And then phosphorus is found in 5A, and phosphorus has 5 valence electrons. To satisfy the octet rule, it's going to gain 3 electrons, and that gives it a 3 minus charge. When we're writing formulas using the swoosh and reduce method, we are going to crisscross the charges so that they become the subscripts of the other element. For instance, we're going to take the 1 plus of lithium and we're going to give it to phosphorus. And we're going to take the 3 minus of phosphorus and give it to lithium. When I write the final formula out, I am going to write those numbers, but I'm going to drop the plus and minus signs. So I have lithium, and then remember, lithium got a 3 minus, so it has a 3. And then I write the symbol for phosphorus, and it got a 1, but we don't write 1, so we're just going to leave it like Li3P. When I look at gallium, gallium has a symbol of Ga. It is found in 3A, so it has 3 valence electrons. So in order to satisfy the octet rule, what gallium is going to do is it's going to lose those 3 valence electrons, and it's going to gain a 3 plus charge. Fluorine, because fluoride ends in IDE. We're going to learn how to name those later, but that is representing fluorine element. So fluorine symbol, F, it's found in 7A, so it will gain 1 electron to satisfy the octet rule, which gives it a 1 minus charge. Again, we're going to crisscross those charges, and then we're going to rewrite the formula. So I have Ga1, but we don't write ones, followed by F, and it's getting a 3. And we have GaF3 for our compound formula. Now, in neither of these cases did we need to reduce, but the final step of the swoosh and reduce method would be to reduce to its simplest form when possible. These examples are in their simplest form, but if we had ended with a 2 and a 2, we would have reduced it to 1, 1, which we wouldn't write. Or if we had ended with a 2 and a 4, we would have reduced to a 1 and a 2. That's what reduced to its simplest form means. Okay, we're going to get to practice this some more in class next time.